Resistors. Resistance is given by the potential difference across a component divided by the current flowing through it. The formula is R equals V over I. The potential difference is in volts, the current in amperes or amps, and the resistance in ohms. A metal wire at a constant temperature obeys Ohm's law, and this states that the current is directly proportional to the potential difference. So a graph of current against potential difference for a resistor that obeys Ohm's law is a straight line through the origin. Here we have current against potential difference, and we get a straight line through the origin. A higher value of resistance would allow less current to flow at a given potential difference, and so give a lower gradient. A lower value of resistance would allow more current to flow for a given potential difference, and so a steeper gradient. The steeper the gradient of a current against potential difference graph, the lower the resistance. Some resistors have a constant value of resistance, as long as the temperature doesn't change. They're called ohmic resistors as they obey Ohm's law, which states that current is directly proportional to potential difference if temperature remains constant. They behave the same whichever direction current flows in, giving a graph like this. This would be a larger resistance with a lower gradient, and a smaller resistance with a steeper gradient. The following resistors do not obey Ohm's law. They are non-ohmic. With a filament lamp, the temperature does not remain constant. As it heats up due to an increase in current, the resistance increases. It behaves the same whichever direction the current flows in, giving a graph something like this. At higher potential differences and higher currents, when the lamp is hotter and is glowing, the gradient of the graph is reducing, meaning the resistance increases. Looking at just one side with some values, we can find the resistance at 2 volts as potential difference over current. 2 volts divided by 2.4 amps gives 0.83 ohms. Getting figures from a different part of the graph, at 12 volts we have 8.2 amps, giving a higher resistance of 1.46 ohms. Just to quickly look at why this happens, with electricity conduction in metals, we have plenty free electrons, and the free electrons will travel from negative to positive, but they will collide with the positive ions on their way, maybe taking a path something like this. As the temperature rises, due to collisions of the electrons with the positive ions, the vibrations of the ions increase, something like this, and so there are more collisions, and thus more resistance. A diode conducts current in one direction when the potential difference goes above around 0.7 volts, but will not allow current to flow in the other direction. This gives a graph something like this. So we see at a negative voltage, with it connected up the wrong way round, or in reverse bias, there is no current, whatever the potential difference. At a positive potential difference, or a forward bias, around about 0.7 volts, the diode starts to conduct, and then has a very low resistance. We normally connect a resistor in series with a diode to prevent too much current flowing when the resistance drops to almost zero. Here we have a graph of resistance against temperature for a negative temperature coefficient thermistor. The temperature rise allows more electrons to be freed and carry the current. A light-dependent resistor gives a drop in resistance as light intensity increases, giving a graph something like this. The light energy in this case frees electrons, allowing them to carry the current.